Assalamualaikum warahmatullahi wabarakatuh. Introduce me, Lina Yuliana. On this occasion, I will explain or review the materials that I have received or learned during the last semester. And here I will explain the calculus material, which is about the first derivatives, the second integral, the third limit. Okay, the next one, derivatives. The definition, actually there is no specific definition of the derivatives, but we can say from the symbol that the derivative is f action x. And the derivatives is actually the ratio between the difference or change in f with change in x. And the change in x must be close to 0. So, the derivatives is the ratio of the change in the function f or because the delta x is close to 0. And for derivatives can also as limit f action x equals lim h approaching 0 f parenthesis x plus h close parenthesis means fx h. Well, here's the definition of the derivatives. So the conclusion is that the derivative is the change in fx divided by the change in x. But the change in x or h is close to 0. So that's the basic definition of the derivative. If there is a question, fx equals 5. Now 5 are constants, and because there is no x here, so whatever the value of the number is, if there is no x, the derivatives of the function is 0. The second, if we have fx and then there is equals ax, then the result of the derivatives is just a. Example, fx equals 5x. So the derivatives is just 5. So we only take the numbers. The third, fx equals a times x power n, maka f action x equals a times nx power n min x. If there is ix power n problem, then the f action x is n. We will lower it forward to a times nx power n min x. Example, fx equals 3x forward squared. So we reduce it to 3 times 2x forward to min 1. The next slide is about trigonometric derivatives. These friends, you can see there are various trigonometric derivatives formulas. I'll go straight to the example. Example, fx equals 4 sin x. f action x equals 4 cos x. The second is integral. The definition, integral is the opposite of differentiation. Integral symbol writing. Fx dx equals fx plus c. Integral basic formulas. Integral ax power n dx equals ax power n plus 1 per n plus 1 plus c n next min 1. Example 1. Integral ax forward and dx equals. So we follow the comments according to the formula above. Equals 6x forward 1 plus 1 per 1 plus 1 equals 6x forward squares per 2 equals 3x forward squares. Curtain integral. Curtain integrals are commonly used to calculate the area of a region bounded by the y equal fx curve and the x-axis is with a curtain limit. Slide. The basic formula can be seen below the slide. Curtain integral properties. And below are the properties of the indefinite integral. You can pay attention to her properties below. Indeterminate integral formula. Integral ax forward and dx equal a parenthesis n plus 1 close parenthesis x forward n plus 1 plus j with the provision of n kill min 1. Example, integral 9x forward to dx. Jadi jawabannya integral 9x squared dx equals 9x forward 2 plus 1 third plus j equals 9x forward 3 third plus j equals 3x forward 3 plus j. The next third is limits. The definitions. In general, the limits of the function can be written like this. Lim x approaching c fx equals L. If lim x plus c positive, fx equals lim x plus c negative fx. When lim x plus c positive fx equals lim x plus c negative fx, then it is said that lim x approaching c fx equals L. No value. Functions limit form. 1. Limits of algebraic functions. It saves limbs x approaching c fx. Limit the functions of the form approaches a value of a with the general equation, namely, if the variable is close to a, where a is a member of a real number L, then the steps for solving the limits of the functions are 1. Direct substitutions on unknown functions. Conditions. The result cannot be an indeterminate number, namely 0, zeros, or factoring the known functions, the simplifying to get the results. 2. Saves lim x approaching proof to fx. The limits of the function in the form of uppercase a value of with the general equation. Lim x approaching proof to fx. How, to how to determine the limits of algebraic functions if the variable is in the following two ways. 1. Divide numerator and denominator by the variable that has the highest power in the equation the function. Lim x approaching proof to fx power v gx power q equals ax power v bx power q. 2. Multiplying by its comrade factor. Parentheses by min q close parentheses. 2 root a plus b